built. I'd love to see this going. Some of them are designed for, I'll talk about the different types. Also, you need to have someone who knows about the system and can measure the voltage and knows what they're talking about. So you need to have a local operator who is knowledgeably trained. Quite difficult to do. And you also need to do maintenance of a battery bank pretty much daily. You need someone to look at the voltage, make sure it's all okay, and definitely monthly you need to check the water in it, you need to check that everything's clean, everything's working. A lot of issues with batteries, they're really annoying. We've got two types of regulation. So I said a charge regulator will stop a battery being overcharged. This type of charge regulator here, can't really tell, but apart from that I know it because it's very small and light, is a series charge regulator. You can only really use this if you can open circuit the generator. So photovoltaics, you can actually open circuit the generator and no bad thing will happen because of that. With a wind turbine, if you open circuit the wind turbine, it's not controlled. There's no control over the output, therefore it will start to spin faster. And so this could be destroyed by series regulation. You have to use a different type of regulation for wind turbines and for microhydro. For any kind of rotating generator, you need to start to use a different type of regulator. But for solar, you use these relatively cheap ones. These two are both series regulators. They don't need a big dump load. They don't actually consume that much power because when they're open circuited, there's no power flow. Generally what you do is you look at the voltage of the battery bank. If the voltage of the battery bank is too high, you open this switch and you stop any power going into the battery bank. That's the situation. It's a little bit cleverer than that, but that's basically what's happening. Shunt regulation, which is what this is. I know that because it's big and heavy. And this is also a shunt regulator, so it has a relay to control a load, which is the light bulb. So what that does is rather than open circuit, it removes the current, the power, excess power to a load, a dump load. So you look at the voltage, when it's too high, you apply a dump load, and that causes, it stops the voltage from rising. You push the power away somehow. Generally, it's pretty difficult to use that usefully. Again, it's kind of heat. There's a nice dump load here, which I think was probably quite expensive.
I didn't buy that one.
Yeah, it was about 60 odd quid from Final.
That's not that bad actually.
You know, using a shunt regulation in like a hydro system,
Yeah.
would it not be quite useful to use the dump load to power some of the water going back up into the...
You could do, yeah, there are a lot of ways people have said about using that power effectively.
Yeah.
Well, as soon as you say it's a dump load, people go, wow, why are you dumping it? That's not efficient.
Yeah.
The problem is that if you've got a pump that's pumping water back up, yes, you could do it. Technically, you've got another thing you need to maintain. You need to ensure that it's okay. You have to have a backup system because if anything goes wrong, you have to dump the power somehow. If that pump fails for any reason, it gets clogged with something over, you don't have any control. Therefore, you would still have to have a dump load.
Yeah.
So it's all economics. Everything's economics. It's not economically viable to install that kind of system because the amount of excess energy you would get from that probably, I can't say for definite, but probably wouldn't pay for itself because you would still need a dump load.
Yeah.
Yeah, I mean, yeah. If you are running a dump load on a microhydro system all the time, what I would probably do is just reduce the flow a bit. Okay, so a mechanical controller every week or so, just seeing what's happening. So, yeah, a lot of people try and use the excess energy usefully, but it's very difficult to, especially very difficult to robust and reliably and with cheaply as well.
In that case, rather than just switching the dump load on, would you arrange to say disconnect the battery bank as well, so that if something went wrong with the control system, you wouldn't also completely deplete the battery bank in the process?
Oh, that's true. Yeah, you could do. I mean, yeah. It's not something I've seen done, I've got to say. But yeah, you could maybe, if you might have a fail safe here, so your control gives an I'm alive output, and it will turn off the battery bank, and then Okay, we've got another thing called a low voltage disconnect. So essentially you've got to protect the battery from overcharging. That's one of the worst things you can do. You also want to protect the battery from over discharging. And in order to do that, you use what's called a low voltage disconnect. Now, this one here has a low voltage disconnect built into it. This means that if the voltage goes below a certain value, it will turn off the loads, stop you using any power. It means that if the voltage on a battery goes below, it's probably set at something like 11 volts, it will stop, not allow you to do anything on the output until it's risen to a higher voltage. It's kind of useful. Generally, I've found that if you do install them in a place that's quite remote, people realise that it's turning off their power and they will unwire it and they'll put it back on the battery. So low voltage disconnects are very difficult to get people to ensure that they use it. So I'll show you some systems that I looked at where people had just got rid of the low voltage disconnects. They just hardwired it out because there's still energy in the battery, so we can keep it going. So one other thing I've got is one of my bugbears is designing and installing good electrical system design. So you're installing a system that you want to last for at least 20 years. That's how you should view any projects that you do. Solar panel will last 20 years. Wind turbine with maintenance will last 20 years. Hydro system with maintenance will also last 20 years. People don't seem to apply those same rules to the electrical system. They're happy to twiddle a couple of bits of wire together and put tape over it. You need to ensure that the system's designed to last. Things you need to do, ensure that you've got good battery bank connections. You need thick cable interconnecting batteries. I would suggest on a relatively, 100 watt or bigger system, I would be using big battery bank connectors. So there's a little bit of battery cable. That's what I use for my battery bank interconnectors. I'd also use good quality clamps to fit to the terminals of the battery. There's another thing, if you're installing a number of batteries to produce a much bigger battery bank, so we can increase the amount of energy we store by increasing the number of batteries. If you are going to do that, if I had my system positive from here and my negative from here, these batteries would actually not be used as much, and actually these batteries would be doing most of the work because you have a little bit of resistance in here, a little bit of resistance in here. So this battery would be doing all the work, these two, and it would cause these batteries to fail first. So you need to think about the layout and how you're doing it, and you should take your negative from diagonally opposite from your positive, so that you get all of these batteries are evenly charged and discharged. Little things like that will ensure that the things last longer. Cables have got to be sized correctly. I've got a bit more cable to pass around as always. So there's some, I think it's 8mm flexible cable, and this is solar cable, so this is stuff that goes on solar modules. It's double insulated, that's 4mm with different connectors. So you need to size the cable so that so it's correctly sized for the amount of current it's carrying. So we talked about transmission systems, and it's all related to the amount of current. So you need to ensure that the resistance is low enough so that there's not a big amount of power loss and voltage drop across a cable. There's the equations there, but basically you have to design it right. That's what I want to get out of that. And it's quite a lot of systems I've seen where it hasn't been designed correctly. Good connections, seen it loads of times. You've got a couple of wires twisted together, a bit of tape on, and they think, people think, that will last for 20 years. It definitely won't. Lots of different types of connectors. You've got what's called chocolate block here, screw terminals, got a load of that here. And then also different crimp connectors. So here's a whole load of crimp connectors. I generally use quite good quality crimp connectors. These ones at the end here. There's a lot of different types. And these are solar photovoltaic connectors if anyone's interested. I'll pass that around so you can have a look at. These are battery clamps. So this is the clamp that goes around the terminal of normal size batteries. But again, just do them well. Sometimes you need to keep them clean and dry or else they'll corrode. Fusing